Working with 3D models downloaded from the internet can be a challenge in FreeCAD, especially when they come in as mesh formats such as STL, OBJ or FreeMF. In this tutorial, I'll guide you through the workflow for preparing a mesh file for editing in FreeCAD. We'll cover the challenges and common pitfalls you may encounter when converting the mesh into a usable solid, and then work through some examples of the editing process. Mesh formats represent objects as a collection of thousands, if not millions, of triangles. This makes mesh models significantly harder to modify, edit, or integrate into your designs. Whenever possible, request or download a step file. Step files preserve the model's geometry, making them far easier to inspect, defeature, and edit. I've supplied a link in the description of this video covering defeaturing if you want to learn more. So let's have a look at the workflow of how to deal with and edit mesh files in FreeCAD. Importing the mesh file into FreeCAD. So first we need to import the file into FreeCAD. We can come up to File and Import, or we can use the Open. If we use the Open and pick, say, an STL file, then this opens it as a new document in FreeCAD, and we can see it on the left hand side. If we want to import it into the current document, then we come up to File and Import, and then pick the file. Now you may find that the screen lags with larger STL files. If it does, we can come up to Edit, Preferences, and then on the Display section, we have this Use OpenGL VBO, Vertex Buffer Object. This utilizes the power of your GPU to speed up the performance of the render. We just need to check that and hit OK. Or we can come up to the Draw Style and select Wireframe. As well as speeding up the view, we can see how many faces are produced. So you can see there's thousands of triangles in this mesh. Depending on the mesh format, you may see a message when you import. So if I import an OBJ file, it's going to ask me what type of module I'm going to use. With OBJ files, I find that the alias mesh is the best one to use. At any time, we can change our view back to the normal view. Checking for and splitting components. We need to know if we're dealing with a single mesh or one that's made up of individual components, which are multiple separate meshes assembled together into a single object. So this model of a woodworking plane I know has multiple components. If we don't split by components and skip straight to converting the mesh to a shape, then there's a high risk of the resulting mesh being invalid by having self-intersections. When we're editing meshes, we use the Mesh Workbench. So if I take the plane from the left-hand side, come up to Meshes, come down and split by components, on the left-hand side we have the original mesh, which we need to hide or delete, and then we have the individual components of the mesh. Now it's important to first check to see if we have components by splitting the mesh. If we don't split by components, our evaluate and repair process, the next step, will fail. So if I remove the components, select them and hit delete on the keyboard, and take the original, and come up to Meshes, Analyze, Evaluate and Repair. On the right hand side, I see the options. The mesh is selected, and if I move this up into the task pane, so now we have two tabs, I have a number of tests to run. Now I can run all of them from here. So if I hit Analyze, you notice we have self-intersections. If we look to the left, we can see it's marked in yellow where the self-intersections are. And this is because the components are slightly intersecting each other. If I close, select the mesh, come to Meshes, and split by components, we'll hide the original mesh. And now we can check all of these by selecting one, come up to Meshes, Analyze, Evaluate and Repair. I have my Evaluate and Repair tool. I have the component selected. If I hit Analyze now, we see we have no problems. And we can work our way through the components, checking each one. As you can see, we have no problems. So make sure you're always split by components first. To see if the mesh is manifold solid, select the component or the mesh, come up to Meshes, come down to Analyze and Evaluate Solid. We get a message saying the mesh is solid. Just repeat this for each of the components. So all my components are solid and I'm ready to move on to the next step. If the meshes are not manifold, then we need to use the Mesh Workbench. Again, using the Evaluate and Repair tool to repair that mesh. Check the number of triangles/faces and decimate if needed. As said before, meshes can be made up of thousands if not millions of triangles. To understand how complex each mesh is, we can select them in the tree view and then look on the task panel or on the data tab under mesh. We see points, edges and faces. We're interested in faces, so this is quite a light mesh and we can skip the decimation step. If the mesh has more than say 100,000 faces, or we can feel that the mesh can be simplified further without losing detail, then we can use the decimate tool. I'm going to close the current document, start a new one and import a more complex mesh. The number of faces of this mesh is still quite low. I can lower the detail further to make this even less process intensive. To do that, we come up to Meshes and then come down to Decimate. This tool is designed to reduce the face count, and I can specify the reduction as a percentage or an absolute value. We also have a tolerance. Lowering the tolerance preserves the detail, but the mesh is simplified less, while still trying to keep the original shape recognizable. I normally leave it on defaults, and you can see here I have 50% set. If I hit OK, the number of faces have reduced, but you can still see the form is okay. So we can take this further. Come up to Meshes and Decimate. Let's try another 50% and hit OK. If we click, it's reduced further. We can still see the form is okay. We can see this reduction through the wireframe view. Let's go again. And decimate. Try another 50%, hit OK. We can see the triangles are getting less. Let's come back to the standard view. Once the mesh is decimated, always check, come up to Meshes, Analyze, and Evaluate Solid. If we have problems, then go through the Evaluate and Repair process once again. Now we need to convert the mesh to a shape. Switch to the Part Workbench. Come up to the drop down and pick Part Workbench. Select the mesh from the left hand side, come up to Part, and we need to pick the shape from Mesh. This will convert the mesh into a shape. We have the option to sew shape. This is normally not needed if the mesh is manifold, known as watertight or a solid mesh. We discovered if the mesh was solid when we used Analyze, Evaluate Solid, but for this demonstration, we'll check the option. This is the process of taking individual disconnected surfaces and stitching their edges together to form a watertight solid. The sewing tolerance defines the maximum distance between two edges that FreeCAD is allowed to bridge to close the gap. If the tolerance is too large, FreeCAD may close gaps that should stay separate, causing small details to be lost or merged together. If the tolerance is too small, FreeCAD may refuse to close tiny gaps, resulting in a shell instead of a solid. The typical value is 0.1. This is the default. Let's hit OK. And on the left hand side, we have the original mesh, and now we have a shape. Remember to hide the mesh. Now, word of warning, the sewing operation is computational heavy on the CPU, so it will take a long time for models of a certain size, so it's best to use this only when needed. If the option is selected, a compound of shells instead of a compound of faces is created. This doesn't change the workflow when converting to a solid. If we select the shape, come up to Part, and check Geometry, also found on the icon in the toolbar, we can run a check on the geometry, and it tells us what type it is. As you can see at the moment, it's a shell. We have to convert this to a solid. So let's close, and I can select the shape, come up to Part, and convert to solid. On the left hand side, we now have a solid and we can hide the original shape. So now we have this. If I run the geometry check and run check, we should see that the shape is now a solid. As we can see here, if this check fails, then the mesh may need external repair through tools such as Blender or something like Mesh Mixer. Finally, we may need to refine the shape. If we look at this shape, this is a planar face, and we can see we have all of these triangles in here, which can be refined down to a single face. So we can merge faces all on the same plane. To do that, select the solid, come out to Part, come down to Copy, and choose Refine Shape. Once processing has been finished, on the left-hand side in the tree view, the unnamed body has been hidden, if not hide it, and we have the refined solid. Now if we look, we can see some of those faces have been merged. Creating a less complex solid is much easier to process through FreeCAD. All of the workflows use the same mesh model, which has been provided as a free download so you can follow along. The download link can be found in the description of this video. We'll begin by preparing the mesh and correcting its transformation point, which is deliberately placed off-center in the original model. This is a common issue you'll come across when working with mesh files. Once that's done, we'll use the derived solid in several different workflows. First, we'll modify the model directly, allowing us to edit the derived solid by changing existing features or adding completely new ones. Next, we'll recreate the model from scratch, using the derived solid as a reference to build a parametric version of what was originally just a static mesh. Finally, we'll use the model to create an interface. We'll take advantage of existing features to accurately model a mating part that fits the original model. We'll start by importing the mesh file. Go to File and Import. I'm going to pick this example file. We'll import it and we have the file here. First, we're going to check its position. If we come out to View and toggle Axis Cross, we see that the axis cross is over here and this is out of position. So if I right click and transform, you can see our transform widget is over here on top of the axis cross. So we need to make this easier to transform. Let's hit cancel. Let's zoom in and go through the conversion process. Come up to the mesh workbench. We'll select the mesh and then check for components, meshes, and split by components. We only have one component, so we can click it and hit delete on the keyboard. We're dealing with one mesh. We're just going to evaluate and repair. So come down to analyze and evaluate and repair. We have our options here and we'll go all above test together and analyze. We're all okay, and let's hit close. Final check, come to meshes, analyze, and evaluate solid. This is a solid, so we're all good to go. Next we check the face count, which is here, 7378, and I'm happy with this, it's quite low. Also, it's available here. Now I could move this at this point, but I haven't really got anything to attach to when I transform. So I need some faces and edges. So we'll first take the mesh, come over to the part workbench, come up to part, come down to shape from mesh. We don't need to sew the shape because we know it's solid. We hit OK. Once that's completed, we can hide the mesh or even delete it from the tree view. Next, let's zoom out. I want to transform this into position. Click on the shape and right click and transform. On the right hand side, we can see the mode is Object Origin. Let's change this to Custom. Therefore, when I hover over this, we get the transform widget attaching to different points. On the right hand side here, we have coordinate system as local. We'll drop this down to global. And we've got the X, Y, and Z appearing here. Let's align the drag rotation with the coordinate system. And now I can manipulate my 3D view and place this into position. I'm going to place the widget along this line here and it snaps to the middle. If we click that, the widget is placed. And now on the right hand side, the translation, I can zero this out. So let's zoom out. I add 0 to the X, 0 to the Y, and 0 to the Z, we're positioned correctly now. Let's hit OK. Though we've changed the position of the shape, if I come up to the shape in the tree view and right click and transform, we see that the transform widget is still over here, making it harder for us to transform that shape. This will be solved when we select the shape and come up to Part and Convert to Solid. On the left hand side, we now have a solid. Let's hide the shape and right click and transform. And you notice that the widget has been reset to the 0 location. Let's cancel out. Now the next stage would be to refine this shape. We do this by coming out to Part and then Copy and create a refined shape. So this will be a refined copy. On the left hand side, once it stopped refining, you'll see we have another solid which is refined down. But I'm not going to use this one. I'm going to make it a bit harder on myself because we won't get perfect refine with all mesh files. So for the learning experience, I'm not going to use this one. I'm just going to hit delete and show the original solid. I can now also get rid of the others by clicking on them and hitting delete on the keyboard, leaving me with the original solid, which we'll use in our workflows. In this workflow, we'll modify the derived solid directly. This is ideal for quick changes on simple models such as this. So for this to be successful, then we have to have a reasonable face count, which, as we saw with this, it was quite low. I want to keep recomputes to a minimum, and the feature tree in the part design recomputes as each feature is added. I'm going to delay those to last, so I'm going to use the part workbench. And we'll remove features such as this part here, the text, and say merge two of these cells, using basic sketches and extrudes, and then using Boolean operations. So we start with a sketch. Let's start by removing the text. Now if we look, we can see the text sits on top of this face here. So we need to attach a sketch to this. We can pick any of these faces as long as it's not the text. And my idea is to extrude upwards from the face to cut this out. Let's select one of the faces, say this one, and create a sketch. Asking for plain face, which is fine. Let's hit OK. Now let's position this and simple rectangle around the text. Let's go around here. Drop it in. Right click to cancel, and we'll pull this out. I'm not going to constrain this. You can if you want to. I'm just going for speed. So I've added the rectangle in here. To make this easier, you may want to come in and change the solid. Look at the view, change the line colors, the point colors, and the shape appearance. This will make it easier to see the lines of the sketch. I'm just going to take the sketch and create an extrude. Let's hit OK. We can see the extrude's gone in the right direction. And when we cut this away, we'll remove that text. I'm not going to cut this right now because that will slow things down. So the next feature, I'm just going to add a sketch upon here. I want to remove this plain face. Now for this one, I'm going to pull in some geometry. So we'll use the toggle section view. We can see inside here, we'll toggle to construction mode and pull in external geometry from the model itself. So I want something around about here. Just want a point or an edge because I want to remove all of this in here, and we'll take point up here. I think that's going to be enough. Toggle back out of construction mode and use the rectangle. Attach to one point, then attach to the other. Let's hit close. We can see the rectangle in here. Let's bring this around, we can see it there. Take the sketch and create the extrude. We'll hit OK. Actually, it needs to go the other way. Let's take the extrude, come down, We want the data tab, and we'll reverse it. Let's take one extrude, control select the other, come out to part, we'll create a compound and compound those together. This means we can create a cut with the compound and the model itself, rather than selecting the individual ones. I've forgotten to merge, say, a couple of these cells. So I'm going to do that now and add that to the compound, and we can drag that into there. So I'm going to take this face, create a sketch, plane face to it. Let's change to construction mode. Use the external projection tool. We'll take this point and this one, toggle back out of construction mode and use a rectangle. Connecting up the rectangle, and we can see that it's going to be inside because I've attached to this face here. Let's use toggle section view. That's better. Should have done that first. And we'll come up to here, right click to cancel, take this point, external point, make this coincident, and close. Now that sketch, which is sitting in there, we can extrude. Got 10 millimeters, let's hit OK. Hasn't extruded far enough, we can see it on the other side here. Let's go further and set this to 20. Should be sharing the same face. And we need this extrude inside the compound. It's just a case of taking the extrude, dragging it inside the compound. So now we've got all of the features that we want to remove. We take the one we want to keep, control select the one we want to remove, and create the cut. So we've left all those operations to last. Once the cut's finished, then our features will be removed. We can see now we've got a merged cell, the text is gone, and this feature here is gone as well. And it's also refined down more once we've created that cut. So in this example, we'll start with the same model using its derived solid without first creating a refined copy, and follow a standard part design workflow to recreate the model. Now you'll notice something interesting as we pull it into a subshape binder, as we need an intermediary to allow us to reference its faces, edges and vertices. So let's come over to the part design workbench and we'll create a new body, nothing selected yet. We'll select the solid, which is unrefined, and create a subshape binder. FreeCAD will pause while the subshape binder is being created. In the background, it's actually refining the shape. And this depends on the face count because it's merging those coplanar faces together, reducing the face count and therefore reducing the edge count. And you'll see that when we look at the subshape binder, look at its properties, and you'll notice that the binder will have the refine set to yes. If we hide the original solid, we can see that the binder has refined the shape. So we've got a single face here and we've got merged faces throughout. This process took around about 20 to 30 seconds. But instead, if I delete the binder, come over to the part, and this time take the original solid, come out to part, copy, and create a refined shape. And as you can see, this process will be a lot quicker. So always start with a refined shape. Now, this is not inside the body, so we still need to create a part design subshape binder. So come over to the part design, make sure the solid is selected, the refined shape, and create a subshape binder. You'll see there'll be a slight pause whilst the binder is created. So now we can hide the solid. This may be a bit awkward to see. As you can see, it's partly transparent, and we could use this. We can also come into the binder, come into the view, and we have use binder style. Uncheck that, and we get the standard solid colors. From here, we can begin rebuilding the model using the subshape binder as our reference. So our body is active. We can select the binder or one of the origin planes to offset our sketch from. I'm going to use a face selection and create a new sketch upon that face. So I've selected the back face and I want to recreate this part here. So we toggle the construction geometry and use the external projection tool. And what we're looking for is corners. So I'm going to take this point and perhaps these 2 points as well. And when it comes to edges such as these, the curved edges, you'll notice that we have a number of short edges. Now in mesh geometry, there's no such thing as a curve. It's approximation of an edge. And this is done by creating a vertex and then another vertex and then creating a line between those and connecting them up following a curved path. In CAD itself, this will be replaced by a curve. So this is what we want to recreate with our model. So we could take the top point here and also the bottom point, which is around about here. I've pulled in that line, but we're in construction, so we're fine. I want something to attach to. I'm just using a point on object constraint to guide my curve around here. It's not going to be exact because the STL or the mesh has been approximated. So let's do the same on this side. I'm just going to pull in a random point. Now we can start with our sketching. We'll look face on. I'm just going to sketch this part to start with. Toggle back to normal geometry and we'll use the polyline. At this point you may find that you've got extra points in here. For instance, I don't need this point, but we'll just join up from one. Coincident constraint, connecting to the other. And now we'll come down and I haven't got a point here, so I'm just going to drop a point in. And we'll come over to this point here. I'm not going to connect to it, and I'm going to press the M key to change the mode on the keyboard. And I'm looking for an arc, so you can see the arc comes in around here. And we'll connect up. I haven't connected to this point at this time. We'll use that in a moment to guide the arc. Let's come over to this point, connect. And, well, I've missed that point. We'll sort that out in a moment. Come up to the top, again, hover over it, press the M key to create the arc, and connect up. And finally, press the M key to get the right connection to here, closing the polyline. So you see, after a right click, we have this geometry in here. We still need some constraints. So let's take the arc and this point, use the coincident constraint, which will place a point on object constraint against those. We've got tangency connecting this arc to this line, which is fine. We haven't got any tangency here, so I'm going to take this point and delete it. And we'll move it across, take these 2 points, make those coincident, and take this arc and this line, create some tangency against those. Let's hit OK. And now I'm going to take this arc and this point, using the coincident constraint, which will place a point on object constraint against those. And we can neaten these up with, say, a vertical constraint. And basically, we're fully constrained there. So we hit close. Now I've got the geometry in that sketch. I can pad that. It's going in the wrong direction, so we hit reverse. And this is where these handlers come in handy. I can pull it all the way up to here, and I can see in there and make refinements on the length if I wanted to. Let's hit OK. So we've got our first pad. Unfortunately, the binder will be hidden when we add our first operation. So we need to show that again to add additional operations against that. I'm going to deal with this part here, and we'll see how this division of lines to create an arc, in this case a circle, requires additional thought when it comes to constraining. So I can attach, say, to the binder again, or I could attach to the pad face. Attaching to the binder, we'll create a sketch. This time I'm dealing with this top half here. We'll use the construction geometry. toggled into the correct mode, and use the external projection tool. Let's import some geometry. So I can import this line here, look at that point, and maybe this line, and this one as well. Points on the arc, some random points there. With the circle, we have no center point. So when we create circles, we create it via the center point and then set dimension. These are individual vertices that run around here that are connected to those lines. So to constrain a circle in here, we really need 3 points. So we pick 3 random points. Don't have to be exact. Let's place them. I've got 2 there. Don't worry about that. And that's pulling 3 from here as well. Let's come back out of construction geometry into defining and create circles within here. So we've got our circles. Now let's take the circle and one of the points and create a point on object constraint via the coincident constraint. And we do the same with this point as well. Let's pick both of them, constraining that first selected item to those 2 points, like so. Let's do the same over here. So the circle, and then select the 3 points, use coincident constraint to get the point on object constraint, and that's fully constrained in there. Let's use the polyline, connect up to this point and this one, up to this one, come across this top point here, hover over it and press the M key and look for the arc, which is here, connect up to that point and this one, and repeat on the other side. And close the geometry with this point. So you can see we don't even need this point here. We've got a nice arc that goes around here. Let's hit close. We can hide the pad, and we've also got the shape binder, sub-shape binder there. Just hide that, and we can see the geometry within. Take the sketch and create a pad. We want it going in the reverse direction. We may want to show the sub-shape binder for reference. See it there. We'll pull this back into place, around about 1.5 millimeters, and hit enter. This will naturally refine the shape underneath. Let's hide the binder. We can see that how it's been built. If we wanted to attach to non-planar faces, such as here from the sub-shape binder, then we could use the pad. But if you started out with non-planar face, then the workflow will be as follows. We have the binder in there. I'm just going to hide the pad. Now we're looking for a plane that is near to our non-planar face. So I can attach to this plane here, or we can attach to the XY plane at the bottom. So make sure nothing's selected, create a sketch, and then come out of the sketch. So we've got our sketch within. We can't see the sketch at the moment. We could show it via the View tab and then show plane and show placement, as we can see it there. But this is not needed because we're going to go into the Data tab, pull this out a bit, and look at the map mode. So the moment it's flat face, we'll change that. So when we click on the button on the end to change the attachment, we get that plane and local coordinate system there. At the moment it's connected to the plane. Select the button within, so it's saying selecting, and let's select our first vertex. So the vertex here, reference 2, select the vertex over here. If our origin plane gets in the way, just come over to the tree view, locate it and hide it. Now I can get in and select that vertex. Come down to reference 3, and let's have a look for the vertex here. So you can see that plane is being orientated, the plane of the sketch, to that edge there. Now we just need some offset. So we look towards our local coordinate system of the sketch. We can see the Z is running this way. The way it's pointing is going to be in the positive direction of the Z, and increase that until it sits on the correct plane, offset away from the edge, and hit OK. The sketch is positioned now. If I double click on it, we can see it's positioned in the correct direction. If you end up around, say, this side, when you double click on it, we can always select the sketch and check the map reverse, and then select align view to sketch. It flips it around the right way. In this case, we don't need that, and we're in the correct orientation. And remember, if you're dealing with an in-between view, trying to align it to the camera can be quite hard. So always use the line view to sketch. And here I can add whatever I want on here. Something like this. Let's close that. Remember, this is the binder. So we need to show the pad, and we can add whatever operation we want upon there. If you're still having problems with face count, then we can take the refined copy and use a part workflow rather than the part design, where we'll attach sketches to faces, so plain face, or to vertices and edges, and then sketch within here. Our finished sketch then can be used with basic extrudes, making sure they travel in the correct direction. And we can rebuild the model through a part workflow. But if you don't want to use a part workflow, we can add the sketches in, then come over to the part design, create a new body, and then use the subshape binder to pull these sketches into the part design workflow. And then use the binders to control select them. We'll change the view out of binder style and create our usual pads and pockets with these, using the solid as reference. Another workflow we can use is the cross-section workflow. So we have the derived solid, which has been refined. Come over to the part workbench, and then select the solid and use the cross-sections. This will create cross-sections across different planes. So I could use the YZ plane, and I want to try to capture a cross-section across here. So I know the shape I need to create in the sketch, and we'll change the position of this to 0 millimeters. We have a single cross-section across there. If we hit OK, this may not take. If it doesn't, just back it off a bit. Create the cross-section along the YZ plane. Place this 0.1 of a millimeter and hit OK. So again, this will take some time due to the edges. And there we have the cross-section for that part. And we can use that in the sketch to reference. So let's take another cross-section, making sure the solid is selected. Create the cross-section against this side this time, and we'll move that using the mouse wheel to move that into position. Look from the top, check the intersection, so 5.8, and we'll back it back a bit to 7.5 and hit OK. So we have the back and the front, and we could create a stack of cross sections as well. So this is very good for revolves if we have a circular object and we want to create a cross section through the middle to find our revolve profile. For stacking, we just take the same solid, create the cross sections, looking across the XY plane, and this is where we want to position it. So at the moment it's positioned in the middle. This is important because when we go to the sections, the distance needs to be correct. So if I go 2, you'll see this adjusts. We need to push this right to the top So let's say we wanted 5 cross sections. And then we just take this number here, 21.5, and then divide that by the count, which is going to be 5. As you can see, that's done the maths in there. We still need one more, so 4.3, remember that value, or copy it. Let's change this count to 6, because we need one more. The distance changes. We just need to make that one 4.3, and we can see we have the top one there. If we want both sides, then we need to double this. So both sides, 8.6, and hit OK. That will work away to create those cross sections. And remember, that's all dependent on face count. Less faces, less edges, less vertices, and the less time it takes to create the cross sections. We can now hide the solid. We have the cross sections within. We can use the part design, create a body, and take the cross section, let's take this one, and create a subshape binder. Pulling that into our workflow, and we'll create a sketch on the face of that subshape binder, and it's the same process. Our last workflow is an interface workflow where we want to interface with the object itself rather than recreating it. But this follows very similar techniques. So for this one, we create a new body in the part design, and instead of shape binding the whole of the solid, we just pick the interfacing parts, say where this will be interfacing with a wall or some other mounting object. So I could take this face, create a subshape binder, then I don't need to use the solid anymore. I've got this as a reference to build my interface around. To create a sketch upon there. And well, I want these holes here, so I can pull in some geometry from the holes, making sure we're in construction. We've got these pulled in 2 there. Once again, let's take that one and we'll select it in the elements and hit delete. I'm going to create some construction geometry rather than defining geometry because this is going to be interface. So I need to make sure that these holes are going to be slightly bigger. Once we're constrained, then I can start building my interface. Let's go into defining and create a larger circle in here. Right click to cancel, and we add our dimensions. So I can set this to be, say, 1 millimeter bigger, and make those two equal. And this could be part of some kind of rail that sits in here like so. And I'll just constrain this down. Wanted to make some extra holes in here because now I've got the right size of these holes. Place them in here, make them equals to each other, and now we have our interface which our model attaches to. So there's a few workflows of how to use a mesh file in your projects and the challenges you may experience along the way. Rather than working with meshes, it's best to try to get the step file. This can be much more lightweight to work with because we don't have thousands of faces to deal with. Hope you enjoyed that video, and I hope to see you in the next one. If you like what you see and you want to donate to the channel, then you can do so via Ko-Fi or Ko-Fi at ko-fi.com/MANG0 or via PayPal at paypal.com/paypalme/DarrenBEstone. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/MangoJellySolutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. I thank everybody that's donated so far. It really helps to keep the lights on so I can produce more content and also expand the channel. Thank you for liking, commenting and subscribing to these videos, and I hope to see you again in the next one.